You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your IT Fundamentals certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. In this episode, we're focusing on data throughput units, the measurements used to describe how quickly data travels across a network. From bits per second to terabits per second, these units tell us how much information is being transmitted and how fast. Whether you're configuring a router, evaluating an internet plan, or troubleshooting a connection, understanding throughput is critical. This episode will guide you through the terminology, unit ladder, and real-world applications so you can interpret speed values with clarity and confidence. Throughput units appear in Domain 1 of the ITF Plus exam, specifically under Common Units of Measure. You may be asked to compare connection types, recognize speed formats, or interpret values in Mbps or GBPs. Exam questions often frame this in scenarios, asking what kind of network can support video streaming, or which device supports the highest data rate. By understanding throughput, you're also strengthening your ability to evaluate network performance, interpret advertisements, and resolve connectivity issues. Let's start with the definition of throughput. In simple terms, throughput refers to the rate at which data moves through a network. It is measured in bits per second, abbreviated as BPS. This metric gives us a sense of how much data is successfully transmitted over a connection in a given amount of time. Higher throughput generally means faster and more efficient communication. It's one of the most important performance indicators in any networking environment. The smallest unit of throughput is the bit per second, or BPS. This means that one bit, either a 0 or a 1, is transmitted every second. While this level of precision is useful for explaining concepts, you won't often see BPS used by itself outside of very low speed or legacy devices. As network technologies evolved, larger units became more practical for everyday communication, allowing more data to be moved per second and reported in more human-readable values. Kilobits per second, or KBPs, equal 1,000 bits per second. In the early days of dial-up modems and first-generation mobile data, this was a common measurement. Even today, KBPs is used for low-bandwidth services, such as basic voice transmissions or minimal data logging in Internet of Things devices. Although it's largely been replaced by faster units, you may still encounter KBPs in niche or outdated systems. Megabits per second, or MBPs, equal 1,000 KBPs or 1 million bits per second. This unit is standard for most home and office internet connections. A 15 Mbps connection is sufficient for web browsing, email, and light streaming. Higher Mbps values support video conferencing, online gaming, and multiple users. Understanding this scale helps with interpreting service plans, troubleshooting slow connections, or determining if your network can handle specific tasks. Gigabits per second, or GBPs, are equal to 1,000 Mbps, or 1 billion bits per second. These speeds are found in high-performance networks such as fiber optic internet, enterprise backbones, and data center infrastructures. Local area networks often use gigabit Ethernet to connect computers and servers. GBP speeds allow for faster data backups, reduced latency in real-time applications, and support for modern high-speed demands in professional environments. Terabits per second, or TBPs, are rarely encountered in consumer networks but are essential in global communications infrastructure. 1 terabit per second equals 1,000 GBPs, or 1 trillion bits per second. Large telecommunications providers, internet backbone carriers, and international data exchanges operate at this scale. TBP speeds allow vast volumes of traffic to move across continents, support global streaming platforms, and power large-scale cloud services that serve millions of users simultaneously. One of the most important distinctions in networking is between bits and bytes. Throughput is always measured in bits per second, not bytes. That means 1 megabit per second is not the same as 1 megabyte per second. Since there are 8 bits in 1 byte, you would need an 8 megabits per second connection to transfer 1 megabyte per second. The lowercase b in Mbps tells you it's a bit measurement, while an uppercase b would indicate bytes. Misunderstanding this can lead to incorrect speed estimates or user expectations. Network speeds are measured in bits because this unit aligns with how data is transmitted at the signaling level. Each bit represents a pulse of information sent along the wire or wireless signal. Bits are easier to track in real-time transmissions and allow for fine-grained bandwidth management. Using bits instead of bytes provides a clearer picture of system efficiency and performance, especially when evaluating error rates, packet loss, or protocol overhead. Let's look at some real-world examples of throughput levels. Basic DSL connections may range from 1 to 15 Mbps. Standard cable or fiber internet might offer 100 to 1000 Mbps. High-performance systems and enterprise setups may run at 10 to 100 Gbps. Understanding where each unit fits helps set expectations. For example, you'll know whether your home Wi-Fi can support 4 simultaneous video streams, or whether your business needs a fiber upgrade for faster cloud access. Internet service providers advertise speed using Mbps or Gbps. However, these advertised numbers represent ideal conditions, what the line is capable of under perfect circumstances. Actual throughput depends on multiple factors, including network congestion, signal quality, hardware capability, and environmental interference. You may subscribe to a 100 Mbps plan, but only see 70 Mbps in practice. That discrepancy is normal, and understanding the reasons behind it helps with both testing and troubleshooting. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. When discussing internet speed, it's essential to understand the difference between upload and download throughput. Download speed refers to the rate at which data travels from the internet to your device, for example, streaming a video or loading a web page. Upload speed, on the other hand, refers to the data sent from your device to a server, such as uploading a file to cloud storage or sending an email attachment. Both are measured in the same units, such as Mbps or Gbps, but many internet service plans prioritize download speed due to typical user behavior. Knowing both values is crucial when evaluating performance or diagnosing slowness. Latency is a related but separate measurement that interacts closely with throughput. Latency refers to the time it takes for data to begin moving after a request is made. It's measured in milliseconds and affects the responsiveness of network-based activities. A low-latency connection will feel snappy and immediate, while a high-latency connection may result in lag or delay even if the throughput is high. Applications like video calls, online gaming, and real-time messaging are especially sensitive to latency. The ITF Plus exam may reference latency alongside throughput when discussing network performance. Multiple factors influence actual throughput, many of which go beyond the advertised numbers. The physical condition of cables, environmental interference, and signal attenuation can all affect how much data successfully transmits in a given period. Device limitations are another concern. If your network interface card, router, or switch cannot handle gigabit speeds, your connection will be bottlenecked. Protocol efficiency and packet loss also play a role in reducing effective data transfer. Understanding these constraints helps when troubleshooting or optimizing a network. Advertised network speeds often differ from real-world results. A plan that promises 100 Mbps may deliver significantly less, especially during peak usage hours. Shared connections in apartment buildings or public spaces divide available bandwidth among users. Wi-Fi networks typically underperform compared to wired Ethernet connections due to interference, distance from the router, and physical obstacles. For this reason, it's important not to treat advertised speeds as guaranteed throughput under all conditions. To assess true throughput, many technicians and consumers use online speed testing tools. Services like speedtest.net provide a quick snapshot of your current download and upload rates measured in Mbps. These tools test real-time performance between your device and a remote server. Results can vary throughout the day based on congestion, server availability, and device load. While these tools are helpful, repeated testing at different times offers a more accurate picture of average network performance. You may also encounter terms like bandwidth and throughput used interchangeably, though they refer to different concepts. Bandwidth represents the maximum capacity a network connection can theoretically handle, while throughput refers to the actual amount of data transferred successfully. For example, a connection with 100 Mbps of bandwidth might only deliver 70 Mbps of throughput due to inefficiencies or contention. While the ITF Plus exam may simplify these terms, it's helpful to understand the distinction for real-world troubleshooting. Expect to see various exam questions related to throughput. One type may ask you to compare units, such as determining which is faster, 500 kbps or 20 Mbps. Another may describe a scenario involving a specific task, like video streaming, and ask which connection is sufficient. You might also be asked to identify which unit best fits a high-speed data center versus a typical home network. These scenarios test your ability to estimate, classify, and convert between units while applying context. To memorize the order of throughput units, use a simple mnemonic: kilo, mega, giga, tera. Each step increases by a factor of 1,000. This sequence helps when doing mental math or interpreting specifications. If a device supports 1 gigabit per second and your current connection is only 100 Mbps, the GBP's connection is 10 times faster. Understanding this progression improves your ability to select equipment, evaluate upgrades, and explain performance expectations to users or stakeholders. Knowing when to use each unit is part of becoming fluent in IT. For example, Mbps is common for home and office internet service descriptions, as well as for Wi-Fi speeds. GBPs is used in high-performance enterprise networks, data center interconnects, and backbone routers. Tbps is reserved for discussions about internet service provider backbones, submarine cables, and major telecom infrastructure. Recognizing the scale and context of each unit ensures accurate interpretation and communication. In addition to knowing the units themselves, it's important to understand how protocols and equipment influence throughput. For instance, full duplex Ethernet allows simultaneous upload and download, improving overall performance. Quality of service settings on enterprise switches can prioritize traffic types to preserve performance for critical applications. Network interface cards may be rated for one speed, but only perform reliably at lower levels if driver or system support is lacking. These technical variables shape the final throughput a user experiences. Wireless environments often require extra consideration when measuring and interpreting throughput. Wireless interference, signal attenuation through walls, and device compatibility all affect performance. A wireless network may advertise theoretical speeds of 300 Mbps, but actual performance may hover around 100 Mbps or less under real conditions. Understanding how physical and environmental factors impact wireless throughput is essential for accurate planning and configuration. It's also useful to be aware of marketing inconsistencies. Some manufacturers list speeds using Mbps, others use Mbps, which causes confusion. Mbps refers to megabits per second, while Mbps refers to megabytes per second, and the latter is 8 times larger. A download speed of 100 Mbps translates to about 12.5 megabytes per second in real terms. Clarifying the unit and case, whether bits or bytes, prevents misunderstandings about speed claims or expectations. To summarize, throughput is measured in bits per second and reflects how much data travels through a network in a given amount of time. The unit ladder, BPS, kbps, mbps, gbps, Tbps, represents increasingly faster data rates used across home, business, and global network environments. Real-world throughput is shaped by hardware, environment, protocol efficiency, and user behavior. By mastering these units and their applications, you'll be equipped to read specifications, evaluate services, and perform well on the ITF Plus exam. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.